All right, in this video, I'm going to go over section 6.5, the assessing normality. So here in this section, we're going to learn, we're going to present the criteria for determining whether the requirement of normal distribution is satisfied. So the criteria involve visual inspection of a histogram to see if it is roughly bell-shaped, or identifying any outlier, and constructing a normal quantile plot. So simply saying that in this section, we're going to study how to determine whether the given data is the normal distributed. Okay, so for given sample data, but it should be the largest size of sample data. Okay, so there are three the way to figure out that is visual inspection of histogram. So we plot the histogram, and then also to see that the histogram is similar to the bell-shaped graph, okay, or identify any outlier. If there is more than one outlier, then it's likely to that the sample data is not normal distribution, or constructing normal quantile plot. So we're gonna study how to plot the normal quantile plot using calculator. Okay. So first of all, normal quantile plot. See, what's this normal quantile plot? So normal quantile plot or normal probability plot is a graph of points x, y, where each x value is from the original set of sample data, and each y value is the corresponding z-score. Okay, that is expected from the standard normal distribution. So for each the sample data, we're gonna calculate the z-score. Okay, and then we just construct the points x, y using the sample data, and then their corresponding z-score, and then we plot those points in the xy plane. Okay, so you can see how to do this one manually, but I'm not going to cover that. Okay, because easily, we can plot the normal quantile plot using calculator. So I'm going to introduce how to do that using calculator. Okay, so let's see, procedure for determining whether it is reasonable to assume that sample data are from a population having a normal distribution. See, histogram, I told you, construct a histogram. We know how to do it, right? Because the beginning of this course, yeah, we learned how to plot the histogram using calculator, right? So if the histogram departs dramatically from a bell shape, conclude that the data do not have a normal distribution. Okay, and then we'll see several examples, histograms that are not normal distribution. Okay, we'll see. The outlier, you identify outliers. If there is more than one outlier present, I told you, conclude that the data might not have a normal distribution. Okay, and the normal quantile plot, if the histogram is basically symmetric and the number of outliers is 0 and 1, use the TI-83 or calculator to generate normal quantile plot. We'll see. So the first one, so first we apply following criteria to determine whether the distribution is normal. Okay, so these criteria can be used loosely for small samples, but they should be used more strictly for large samples. Okay, so normal distribution, the population distribution is normal if the pattern of the points is reasonably close to a straight line and the points do not show some systematic pattern that is not straight line. And see, what if the graph? Yeah, I think we need to look at the examples of the normal quantile plot first, and then I'm gonna explain how to figure out whether or not this is graph of normal quantile plot shows that the sample data is normal distribution or not. We'll see. So here, look at this. This is the left graph. We see the two figure, right? The left side, the graph on the left side is histogram, and the graph on the right hand side is the normal quantile plot. So it's the x value. I told you x value represent the sample data, and then y-axis represent the corresponding z-score. And then you see these you see the points right there. So the points are approximately lies on the straight line, right? So then in this case, we can see that, oh, then the sample, that sample has the normal distribution. Okay, see the first cases show a histogram of IQ score that is close to being belly shape. You see that also look at the histogram. This is a belly shape, right? Roughly, we can say that. Okay, so it's the normal distribution. Yeah, the corresponding normal quantile plot shows points that are reasonably close to a straight line pattern. Okay, and the points do not show any other systematic pattern that is not straight. Systematic pattern is what systematic pattern? Look at this. Second example, this example of uniform example. So when you look at the normal quantile plot, the second graph, so the points, distribution of points has some kind of pattern. This up and this wave kind of pattern is kind of wave, right? Up and then down and up, right? So even though the points, distribution of the points lies, points lies on roughly on the straight line. If you see there is this pattern, right? That means that sample doesn't have the normal distribution. Okay, so see the second case show a histogram of data having a uniform flat distribution. The corresponding normal quantile plot suggests that the points are not normal distributed. So although the pattern of point is reasonably close to straight line, I told you, but there is another systematic pattern that is not straight line pattern. Okay, so we conclude that these sample values are from a population having a distribution that is not normal. Yeah. Okay, and then the last case is this. Now look at the histogram. It's a skewed to right, right? So if you when you look at the histogram and then there is a long right tail, then we can say that it is skewed to the right. Then look at the corresponding normal quantile plot. Most of data is gathered in the just left hand side, right? Okay, so you see that. So when you look at the when you get the that kind of the normal quantile plot, then you may just conclude that, oh, then that sample is not normal distributed, and then the sample is graph, but distribution of the sample is normal skewed to the right. You can say that. So the third case shows a histogram of the amounts of rainfall in inches in Boston for every Monday during 1 year. So the shape of the histogram is skewed to the right, not bell shape. The corresponding normal quantile plot shows points that are not at all close to straight line pattern. And even this graph, the data doesn't have a systematic pattern. Okay? So these rainfall amount are from the population having a distribution that is not normal. Okay, so back to the here. Now normal distribution. What circumstances we can say that we can conclude that from the normal quantile plot, the population distribution is not normal if either or both of these two conditions apply. The points do not lie reasonably close to straight line. The points show some systematic pattern that is not straight line pattern. Okay, so keep in mind that. So now let's see. The textbook just introduced how to plot the normal quantile plot manually, but I'm not going to cover that. Instead of that, I'll show you how to do this using calculator. All right, so in the calculator, so first one, you need to enter the data first, right? So for me, we press that and then go to edit. So I just enter the data in example 1 in a textbook. Okay, that's the just part of the sample data of the old-fashioned gauger. So, and then that data represent the time elapsed to the eruptions, gauger. Okay, so I enter that. Okay, and then I want to figure out if this data is normal distributed or not by graphing normal quantile plot. Okay, so what you're going to do once you enter the data here, and then we go to the step plot. Okay, this is step plot right there. So press second and then step plot. So now the key in mind is plot one is the on and the other plot is off. Okay, enter. And then we choose there are 6 type of the graph here. The last one is the normal quantile plot. Okay, so you said this is this is the histogram, right? And that's the for the outlier graph of outlier, right? So this is the modified outlier with the that's an outlier, the graph outliers and also outliers. Okay. Now, but the difference between one is that these are just we use those two types to plot the box plot, but the left one give us the show the outliers. Okay, that one doesn't. So now we in data list we enter the list number, what you enter the data, okay, and then we choose X because the L19 is that column we enter the data, right? So we choose the data axis X. Okay, it means the we set the data entered in L19. We use that as X values. Okay, and then you choose one of the mark. Okay, one of them should be fine, and then we press Q, and then we press 9. Okay, now you see that here. Then you can just imagine that there is a straight line like this. Okay, then you see, obviously all those points do not lie in the straight line even closely, right? So we can see that, oh, then that data is not normal distributed. Okay, so now let's see how to plot the normal quantile plot. All right, so when you look at the examples, all the faithful the Gazer eruption times, the textbook, they use all the data in sample 250 eruption times listed in the data set in the appendix B. Okay, so now you can import. You don't have to manually enter all the data in the calculator, 250 data into calculator, and so you can import data into your calculator by using the cable. I think USB cable to your laptop and your the calculator, and then you can figure out how to do it using how to do it explaining that instruction using the YouTube. Okay, so now or textbook. Let's see, now the when you plot the quantile plot of 250 data, you see this. Okay, definitely this is not the that data sample is not normal distributed, right? So now let's use a display with the 3 criteria for the assessing normality. So histogram can be created using TI-83 calculator. Okay, so histogram would be skewed to the left and far from bell shape. Yeah, if you just plot the graph of histogram of this data 250 eruption times, you will see the skew to the left. Outlier examination of the sorted list of 250 eruption times revealed that the 20 lowest times do appear to the outlier. I told you the you can figure out how many outliers we see by by plotting box plot with outliers. Okay, and then let's see, last one, normal quantile plot. We did that, right? We showed that. So for this section, yeah, let's recap. So what we study here in this section, we study the 3 ways to determine whether or not the given sample is normally distributed. The first way is histogram, second one outlier, the third one is normal quantile plot. Okay, so let me stop here.